Hi, Assalamualaikum. Today, we continue with the lecture on the wave and vibrations for station. This video, we discuss about the MassSpring system dealing with the force. So I hope you still remember the simple motion of the MassSpring system as well as the pendulum. Then the damping part of the MassSpring system. So what's the different compared to the simple motion and then with the damping part of the MassSpring system? Imagine that we have a MassSpring system here. So we have MassSpring system, it's still similar MassSpring system with the spring constant K, mass of the spring will be M, and then we have the external force here, when as of F naught cos T, which is cos omega T. F naught cos omega T is a given force to the MassSpring system. And then they still have the damping here. I've not put in this video. We have at least they have a PV. So this is something interesting because we have another omega here, which is omega that given to the system. It's not the omega for the spring, because the omega for the spring system, which is we can give here, is omega naught. Omega naught equal to square root K over. Remember? So that will be the omega naught, or the natural frequency to the system of mass spring. Right now, the mass spring is not oscillate by their own, but we're given to the extra force, additional force to the system. It will follow the additional force. That will be what we need to focus. We have omega here, and the oscillation for the external force is F naught cos omega T, and given another way. Example, we can see from if you know that the swing, baby swing. So this ordinary swing, we have a spring system here, and we put baby here. Then okay, so then when we oscillate, it will oscillate. Okay, we will pull here, and then the swing will oscillate up and down, up and down. Then at a certain time they will stop. So that's why people sometimes buy what we call as some automatic baby swing. So it happens something like this. They have additional part here that control how fast they want. So even though we are not being there, so the swing can still oscillate. So those who have a baby, we know that it's a will keep your baby sleep for longer time. So that would be example on the real part of the MassSpring system. So now, remember you for the damping and also the MassSpring system that we discussed before, simple harmonic. So we have here Newton's law, Hooke's law, and damping here. So right now, they have an additional F naught cos omega T here. Instead of equal to 0, so they have an additional F naught cos omega T. And when we change the everything, okay, remember M, and then A is a M d square x over dt square. We have here V is a x dx over dt. And also we have here kx equal to cos omega t. So what we have here is similar, except we have another extra f naught cos omega t, and then we can bring here m to here, so it become b over m, k over m. Also we have here f naught over m. Finally, you can get this equation. D square x over dt square plus gamma b over m is equal to gamma, b over m is equal to gamma. Then we have omega naught square, which is k over m, square root k over m. K over M, then equal to F naught cos omega T. So right now, I need to assure that we have two different omega here. We have omega, the pure omega here is omega that given to the system, which is the driven frequency. The driven frequency means that the omega that given to the system to move. But the omega naught we call as a natural frequency. Natural frequency. The original, or can call the original, means that when we are doing the simple harmonic motion, we have the omega. So that will be the omega naught, the natural frequency. So we have two different frequencies. And we know already what is omega naught, but we doesn't know exactly what the omega. But the omega actually being given to the system. So we enforce to the MassSpring system to follow the omega. So is it we want to make it fast or slow? It depends on the omega, not the omega naught. So what we're dealing here is what we call as a steady state solution. So now, to deal with this equation, okay, I bring here so what we have here, this is maybe the basic equation, okay, omega for this, okay, that's we have discussed before. And to dealing with, we have the complex function here. We're using the complex function. So we change x into z, which is x is a real part of the z or z. The z is equal to a exponential j omega t minus gamma. We are using omega, not omega naught, omega. So we change everything to the part of the complex. And after this, when the final, we can change back to the real part. So we have d square z over dt square plus gamma dz over dt plus omega naught times z equal to f naught omega. So for cos omega also we change to the complex, which is exponential j omega t. We know that exponential j omega t is equal to cosine omega t plus j sine omega t. But right now we are taking only the real part of the equation. So we change to the complex here. Again, from z, double differentiation, okay, differentiate dz over dt. So we know that the basic differentiation, exponential a is a constant, differentiate exponential, it will stay exponential j omega t minus gamma, and then they will differentiate inside. Sorry, theta is will remove. We have here omega t, so at least we have here j omega in front. Then we know that a exponential j omega t is z, so we can have here j omega z. D square z over dt square. Again, we have j omega. So j square is equal to minus 1 because j is equal to square root minus 1. So j square is equal to minus 1. We have omega square. And still a exponential j omega t is a z. So still have here what we have j omega z for dz over dt minus omega square z for d square z over dt square. And we keep maintain the z. So what we have here, I think better for me to just copy here, make it easier. So we have d square z over dt square. So for d square z over dt square is minus omega square z. Okay. Plus gamma. So plus, we have here gamma. Plus gamma. We have here j omega z. J omega z. Yeah. Then plus omega naught square z. Okay, plus omega naught square z. Right? Equal to f naught m j omega. Right. We have f naught over m j omega e. From here, sorry, I think okay, because Z still here. Okay, I need to put the value of Z here. So we have here minus omega square plus J gamma omega plus omega naught square. Then the Z here is A exponential J omega T is equal to F naught for M exponential J omega. So what we have here, J omega T. So we know that exponential J omega T is equal to exponential J omega T times exponential J delta. So we can cancel up this minus J delta. We have minus here. So we can cancel up this J omega T with the J omega T. And we bring exponential minus J delta to here. So we have here exponential J delta. Okay. So because of the negative here. And finally, we can have this equation. We can split into two because we have here real part. This one is real part. And this one is a real part. Because we need to split it here. Okay. We have another step here. We have minus omega square plus A gamma omega plus is something that we try to find here. A equal, because everything we bring in the right side and the J omega T is cancelled. We have here F naught over M exponential J theta. We can split the Euler. Have here cosine delta plus D sine theta. Not appear in the alright. Because the exponential J delta is equal to cos delta plus J sine theta delta. So we have here cos delta plus G from here. We can split into two part, which is the real part and imaginary part. So we have here real, real, real part, reading this, and we have imaginary part because we have G here and also here. So we can split into two, real part and imaginary part. We split and try to solve. So for the real part, we have omega naught square minus omega square for times A equal to F naught over M cosine delta. For imaginary part, we have gamma omega A F naught M equal to F naught M delta. And to solve this, we know that cos square delta plus sine square delta can get equal to 1. So we square everything here. We add up both of the equation. What we have here. So we add both equation here. So we have omega square minus omega square. A square plus gamma A both of it square equal to F naught M cos square delta plus F naught square F naught over M square sine square delta. We can factorize this. So we have here cos delta plus sine delta. This is equal to 1. We have here, and then we have A square. Both have A square. We maintain here A square is equal to F naught over M square. Can bring below here we have omega naught square minus square plus gamma omega. Since that a square, we have here a square. So square root this f naught over m, and this one is the. Finally, you can get this equation for the a, quite complex value for the amplitude of the force driver, so driven force on the MassSpring system. So what happened here? Okay, and then for tan data we can get here equal to gamma omega over a minus. So here I write in here. Right now they have three different situation, and I believe that sometimes it's quite difficult to imagine unless we can have a example that we can explain later. So for three different situation, when the driven force means that the force given to the system, to MassSpring system, imagine that we have a baby swing there. The system will took very small frequency. The frequency which is omega is really small, which is near to 0. Okay, very near to the 0 because the frequency is very small. What happened? So the period means that the system, the driven system, need a longer time to complete one cycle because the omega is very near to the 0. So what will happen here? You can see that from this equation A, the omega is equal to 0. Omega is equal to 0. So right now the amplitude will be F naught over M omega naught, which is omega naught square is equal to K over M, remember? So K over M, M cancel, we have here F naught over K. So this will be the amplitude for the driving force when omega is really slow. And what happens if omega is near to omega naught, which is the natural frequency? So the spring system, they have their own frequency. What happen if we give the force, which is the omega similar to the natural frequency or the spring frequency itself? So what will happen to the system? So by mathematically, we can put the value because the omega is equal to omega naught. So the value here will be 0. The left here, omega gamma is equal to omega, which is omega now we know is similar to the omega naught. What we have here is A equal to F naught over M. We still have a gamma omega naught. So this will be the amplitude. Next, the next situation when the driving force, when given to the system, MassSpring system, what happen if the driving force is really fast, which is very near to the infinity? What happened? So of course the period will be 0. So what we have here, the amplitude will be 0 because the infinity here. And then we have here delta. What is delta? The delta will be the difference or the phase difference between the driven force and the natural frequency of the MassSpring system itself. Example, so the MassSpring system, and we put the box here for the driving force. Okay, so means that the delta is the difference between the movement of the MassSpring system with the box itself, because the box itself, they have their own frequency. Okay, they oscillate. So I think it's very simple when we discuss about the pendulum data. So that will be I will try to show you how the physical way to explain these three different situations. So the delta itself, by the calculation, the delta, because of the f naught k, because omega is very near to 0, so we have a delta is equal to 0. Means that because of the system move really slowly, so the MassSpring system also will follow the oscillation of the driving force. So the difference will be 0 because they follow exactly where the goes. For the driving force for delta, driving force is equal to natural frequency. The delta is equal to pi over 2 degrees. And the last one will be when move really fast. Okay? No amplitude means that this MassSpring system will not move. So only this system will move. In that will happen. So maybe the spring will move, but the mass here, okay, the box here is there will be no moving or right and left here. They will static here. So only the spring and also the system here. So what will happen here? The delta will be the pi. Okay. So the different phase between these two will be pi. And that will be discussion later. So when we convert back to the equation of the function of the x, so we have here x is equal to a cos omega t minus delta, which is a is the amplitude and the delta is the phase between omega and omega. So later we'll discuss, next video we'll discuss on the pendulums, and then we can see that how the example of the physical way to explain this for the post driver post system. Okay, bye. See you for the next video.